Hello everyone. Here we are presenting our innovative project on the design of a plastic formwork, innovative solution for the modern construction technology. So first is the introduction part, introduction of the plastic formwork system. Aim is to design durable, reusable, and cost-effective plastic formwork for efficient and sustainable building constructions. Objectives are to enhance the durability and longevity, to optimize the easy use of high quality form finish, to address wet constraint while maintaining structural strength, to promote sustainability and reduce environmental impacts, to achieve cost efficiency. So we have developed a plastic formwork system, and considering that plastic formwork system, the most important thing is that we are going to replace the traditional aluforms and the wooden formworks by a plastic formwork system where we can use the HDP material as well as we can use recycled plastic. So it has the great environmental impact as well as increase the efficiency of the formwork system as the arranging the formworks and assembling disassembling process, leading, lifting, and weight constraint also. So introduction formwork is a temporary or permanent mold into the concrete is poured. So we are going to make it from plastic. This presentation exposed the design, benefits, and applications of plastic formwork in building constructions. So next is the problem statement. Whatever we are going to deal is to develop a plastic formwork system that overcomes the limitations of a conventional formwork system, such as it has a high weight and it also affect the water cement ratio as well and will enhance efficiency, durability, and sustainability in the construction industry. So this is a methodology how we are going to deal with the plastic formworks while we are going to actual generation of the plastic formwork plates in the industrial. The first planning and design of the formwork done in using the various softwares. Next is the prepare the shop drawings. Next is the prepare the materials we are considering or taking the HDP material and its high strength and high coefficient of the temperature acts in the various conditions, temperature conditions. Next is the set out of a formworks where set out formwork for the making formwork is done. The next is the machine molds are there where we have to going to mold our whatever material HDP we are going to use. Then assembling the actual formworks, monitoring and remnant concrete pouring. And next is the strip and raise support. So all these things can be done on the industrial level whenever we are going to develop our plastic formwork system. So these are the design calculations we have considered. The determination design requirement as we have considered the dimension 230 mm into 300 mm, standard column having height 3 meters and weight concrete pressure as a 72 kilometer Newton per meter square. So property we are considering HDP having density 950 to 970 kg per meter cube. Safety factor of safety we are considered two. Design panel we are considered the panel thickness as all the consideration of the bending moment and sectional modulus. We get the panel thickness as the 65 mm for 230 mm into 300 mm dimension column, as well as allowable deflection here. Calculating allowable deflection, it is a 0.68 mm using the all safety conditions. Then designing the whatever the stiffeners we are going to design, they will be their spacing will be h by 4, that is a 750 mm. After each 750 mm, there will be ribs vertically and horizontally. Design connection. So we are going to make the whatever the HTTP logs which are able to tackle or which are HTTP logs which are essential to interlocking system in a such a easier way that it required the less amount of time, as well as we have to going form a such a system and such connections that there will no requirement of rubber gasket or plastic paper while pouring the concrete, that the water from the concrete or slurry cannot get out. The next is the design summary. So here we have written all design summary. So next is the features of a plastic formworks. So it will be lightweight. So lead and lift process of plastic formworks will be easier. Less number of workers should be required. Fast work should be durable. It will be work for the long time. Reusable. As we consider the steel and the forms have their limitations. That is, they can be used the 60 or 70 number of cycles. But whatever we are going to design the plastic formwork, which can be used the superior finish as well as it can be works for 100. Cycles there. So there is a chemical and corrosion effects are not there. So literally, as plastic is the chemically inert, and there is a no corrosion effect there, and it should be eco-friendly that recycled plastic can be used. So this is a market trend as going on for the plastic formwork. In 2032, the market in the world should be 5.9 US dollars billion market will be there. So ongoing trade considering the growth in emerging market, sustainability focuses, technological advancement, and infrastructure development should be there. So here we have comparative study on the traditional formworks and plastic formworks. So cost is a medium to high in the traditional formwork, and plastic formworks is low initial cost or low usability cost, we can say it. So ongoing trades are widely used in traditional formworks, but plastic formworks are increasing popularity. Strain to weight ratio as a moderate in a traditional formworks, but in plastic format it gives a high strength in the low weight. So time required for the work should be in plastic formwork is less, as well as the moderate buckling resistance should be provided by plastic formwork. Actual weight will be 10 to 15 kg, and considering the weight constraint of the traditional formwork is 30 to 80 kg per meter square. So required additional plastering in the for smooth surface, but we consider plastic for we get directly smooth finish, does not require additional plastering there. And so this all are compared here. We have also considered the comparison between plastic and plastic. So considering the HDP, polypropylene, as well as the ABS materials, and from all that we get that HDP material having some high cost, but it can be works in adverse environmental conditions. So we have chosen it at the considering the K factor or the temperature factor is the high in case of the HDP material. So sustainability aspects we can consider reusability, recyclability, low environmental impact, lightweight and energy efficient, durability, reduce carbon footprint, and all this can be considered. So here applications of and conclusion should be written. Application it is widely applicable considering residential buildings, walls, slabs, columns, and all over. Infrastructural projects ideal for bridges, tunnels, and retaining walls due to its lightweight. Affordable housing project it can be used. Temporary structures, retaining walls, scaffolds, all this. Water retention structure, so it cannot get affected as the wooden formworks absorbs the water and get buckled, and whatever we are considered the alloforms get corroded. But considering the plastic form, they can be used in sewage treatment plant and all where there is a no any impact of the what we can say no any impact of the uh, chemicals or water on it. So generally, we are focusing on efficiently increasing or efficiently done the plastic formworks as our innovation first is in a material choosing that we are going to tackle with the HDP. Whatever the available in the market are not with the HDP, they are with the polypropylene, but we are going to tackle with the HDP, high density polyethylene, and their 3D printing on the 3D printers, as we can give the customized plastic formworks to the customers. As well as the next thing is we are considering or forming the locking system in such a way that it does not record the rubber gasket and the plastic papers there. So next is the conclusion to design the plaster, improve durability. It improves durability, reduce environmental impacts, increase efficiency, enhance quality of the construction. Challenges while doing that is material limitations as HDP has a various limitations in its own manner. The next structural integrity should be required as it can be worked for the high pressure of the construction site, and as well as the cost maintaining is also one of the challenge as we consider 3D printing and all the systems. So here the future scope has increased the adoption adoption in the sustainable construction, technological advancement, enhancement, durability, cost reduction, and integration with the modular construction. So all these are the future scopes of our project we are considering. Reference that we consider the IS code as a IS 14687 199, the special IS code for the form of design systems. Thank you. So this is all about our project.